Hey good people, Arthur Moore is here. I hope all is well. In this video we're going to look at inverse functions. So from previous lessons, previous courses, it says that for instance let the function f of x equal x plus 3 and from a equals the set of 1, 2, 3, 4 and b the set of 4, 5, 6, 7. We can write those as ordered pairs to match up 1, 4, 2, 5, 3, 6, and 4, 7. Well, by interchanging the first and second coordinates of each ordered pair, you can form the inverse function of f. And the inverse function is f to the negative first. So it is a function from b to a that can be written as, so you just swapping around the first and second coordinates. So we'll go from 1 4 to 4 1, 2 5 to 5 2, 6 3, 7 4, and so on. Okay. So it says note that the domain of f is equal to the range of f of negative 1 and vice versa. So the functions f and f to the negative first have the effect of undoing each other. Okay, that is when you write the form, the composition, a composition function of those functions, you would end up with just x. They just undo each other. So again, keep in mind these two tips right here. Okay. All right. So to first of all, here we want to match the graphs with their inverse, the functions with their inverse functions. So one way you can do that is to find a couple of points on the graph and then find the inverse. So let's go maybe 1, 2, and let's see here, maybe 1, what's it, about a half. So 1, 1/2. See if we can find the inverse of those. So you would just look at the other functions. You want to find something that kind of looks similar but flipped around some way. So let's look at maybe number 11. This 2, 1. So we see that that's an inverse, and then 1/2 and 1. So I would say that 11 and a are inverses of each other. So 11 and a are inverses of each other. Now b, let's see, we have 1, 0, and this one here 0, 6. So we want to go back over to the graphs and see if we can find the graph that has the point 6, 0 and 0, 1. So here on number 10 I see I have 6, 0 and I have 0, 1. So number 10 and letter B are inverses of each other. All right, C, the only other line that I have is number 9. So but let's check just to make sure. I have negative 2, 0 as a point, and then I have 0, 2 as a point. So my inverse of that would be, for negative 2, 0 will be 0, negative 2, 0, negative 2 right here on number 9, and then 2, 0, 2, 0 right here. So number 9 and letter C are inverses of each other. So it leaves 12 and D. Let's just check it and see. How about, looks like 3 and about a half. We'll call it 1/2. So let's come back over here to 1/2. Let's see, 3 and 1 and 1/2. Sorry, let's call it 1 and 1/2. So 3. That's not a good. Let's see. No, yeah, 1 and 1/2, and 3 about right there. So we can see that that works out to be an inverse as well. Okay, so that's how you can do the graphs there. Okay, so guidelines for finding an inverse function, and you may want to pause the video here and write down these steps. Okay, so we're going to determine whether the function y of x equals f of x has an inverse. We're going to solve x as a function of y. To do that, after we do that, we want to interchange x and y, and that resulting function is the inverse. And then we define the domain of the inverse as the range of the original function. And then we verify that the composition functions gives us back x back out. Okay. All right. So step A, find the inverse function. So to find the inverse function, uh, first of all, let's write this in terms of y and x. So let's write it in terms of y and x. Okay, now we want to interchange x and y. And then we want to solve this equation for y. So I would add 1 to both sides. So that tells me y to the third equals x plus 1. And then the cube root of both sides. Therefore, my inverse of my original function is equal to this one here. So we would say the inverse of the function of x equals the cube root of x plus 1. Okay. And then part B asks us to graph this. So we can just graph this, and you can use Desmos if you choose to. All right, so just make a table or do a few points. So for x to the third, the function of x to the third minus 1, then we know that if we plug in 0 for x, then we get out negative 1. If we plug in 1 for x, we get out 0. And if we plug in negative 1 for x, negative 1 to the third is negative 1, we get out negative 2. And let's say we plug in maybe 2 for x, we get out 7. Okay, so let's see what we have. I'll plot this in blue. Okay, so 0, negative 1. And then 1, 0. And negative 1, negative 2. And again, I recommend you do this in Desmos. It'll be a lot more accurate. And then 2, 7. And let's see here. How about we do negative 2? So negative 2 would give us negative 8. So negative 2 and 9. All right, so that graph curves through here, something like that. Okay, and then you would do the same thing for the inverse function. So you would make a table for your inverse function, and you should not, now you can calculate it just to make sure. Let's try one of these for the inverse function, but remember, if it's an inverse, then we should just be able to inverse the first and second coordinate, or the x and y coordinates, from the original function. So f of -1 of x equals, well, we'll just leave it in terms of y. Y equals the cube root of x plus 1. All right, so let's say we had -1. So if we put -1 in for x, -1 plus 1 is 0. The cube root of 0 is 0. So -1, 0, and you see that's just the opposite, or it's just the inverse of this first coordinate that I have here. So let's just write the inverse out. So 0, 1, -2, -1, and 7, 2. Okay, so -1, 0, 0, 1, -2, -1, and 7, 2. And you get something like that. All right, so now what you can see is that this thing flips over where x equals y. That's how you know it's an inverse. We put that dotted line of the graph x equals y. These graphs flip over the x equals y line. That's how you know that the graphs are inverses of each other. Okay, part C says describe the relationship between the graphs. And basically what I just said, the graph reflects over the line y equals x or x equals y. And then part D says state the domain and range. Well, it looks like the domain of the original function. So for f of x, domain is equal to -infinity to infinity. So for f prime of x, or f negative to the negative first of x, the range is equal to -infinity to infinity. And then for f of x, the range is also equal to -infinity to infinity. We don't have any restrictions here. Okay. Alrighty. So that's that problem there. We found the inverse. We graphed. We said it reflects over the y equals x line there. And then we stated our domain and range for the function and its inverse. Okay, let's look at another one. So number 39, we have f of x equals the square root of x. So again, let's write this in terms of y. All right, now let's interchange x and y. And then let's solve for y. So we have to square both sides. Therefore, the inverse of the function is equal to x squared. Okay. And one thing we didn't do, we didn't check it, and you could check it by doing one of the composition functions. So we can check this by doing a composition function of f of -1x. So the original function was x to the third minus 1. I'm going to replace the x with the inverse there. So the cube root of x plus 1 to the third power, and then minus 1. And when we get done, when we do the composition function with that inverse, we should end up with x. So the cube root and the exponent cube will cancel each other out. So that gives me with x plus 1 minus 1, and then plus 1 minus 1 equals x. So that composition equals x. So that's a quick way to check that as well. Okay. All right. So part B, graph this. And again, like I said, you can throw this in Desmos to graph it, or you can sketch it out. All right, so f of x or y equals the square root of x. So my domain, now remember we cannot take the square root or even root of a negative number. So my domain here has to be where x is greater than or equal to 0. So I can start with 0 and get 0, 1, 1, 4. The square root of 4 is 2. And that's pretty good there, I think. So the inverse of that zero zero still, and then 1 1, 2 4. And let's put not one more over here. What about 9 3? So 3 9. Okay, so let's graph that first one here. 0 0, 1 1, 4 2, and 9 3. So something like that. And then the second one, or the inverse, is still 0 0 1 1, but then it's 2 4. So it shoots up here, and then 3 9. So it goes something like that. And if you look here, that's still reflecting over that x or y equals x. Okay, so part B will just be reflects over y equals x. Part C, domain and range. So we want to look at our original function at that domain and range, and that'll help us to determine the domain and range of the inverse function. So for f of x, domain equals, we saw that it had to be greater than or equal to 0. So from 0 to infinity. Range, we saw that that also started at 0 and went to infinity. When we look at our y values, start at 0, 1, 2, 3, 4, and goes to infinity. So those were also positive. All right, so for our inverse, then we'll have just the opposite. So look at the range for the domain. So it's 0 to infinity. And then you look at the original domain, and that will match up to the range of your inverse. Okay. All right, all right, all right. Let's see what we have here. Okay, and I'm going to do one more example problem. We're um, going to use the inverse functions here to find the domains of f and f of, to the negative first. Find the ranges graph, show the slopes of the graphs of f and the function and its inverse are reciprocals at the given points. So my given points are 5 1 and 1 5. So when we look at slope, we'll go back to the calculus part of this using the derivative to help us out. Okay, so the first thing it says to find domain and range. So my domain, remember the square root has to be of a number, has to be greater than or equal to 0, but here we have minus 4. So to see what that is, we can say x minus 4 must be greater than or equal to 0. Add 4 to both sides. My domain is x is greater than or equal to 4. If I plug 4 in there, 4 minus 4 is 0. That tells me that my range would be from 0 to infinity. Okay, so part A. So what I just said there, if I plug this 4 in, I say f of 4 equals square root, replace 4 minus 4 is 0. That tells me that my domain starts at 0. My range, I'm sorry, my range starts at 0 and goes to infinity. Okay, so A, for f of x, my domain is equal to 4 to infinity. And my range is equal to 0 to infinity. And we should have been using brackets there. So the range, because we are including 4 to infinity. Okay. Part B says to find the ranges, and that's what we did for part B. Find the domain. So we did A and B together here, A slash B. And then part C says to graph. So again, you can graph that using Desmos. And part D says to show that the slopes of the graphs are reciprocals. Show that the slopes of the graphs are reciprocals. All right, so to show that the slopes of the graphs are reciprocal, so use Desmos or your graphing calculator, or you can sketch it out for part C. To show that the slopes are reciprocals, we need to find our derivative of each one of those. Okay, so if f of x equals the square root of x, because remember your first derivative is rate of change. F of x equals x minus 4 to the 1/2. And then use the power and chain rule. So 1/2 times x minus 4. Subtract 1. So if we subtract 1, that's subtracting 2 over 2. So negative 1/2 times the derivative of the inside. Derivative of x minus 4 is simply 1. So we have 1 over 2 times the square root of x minus 4. Now the point that they gave us was 5, 1. So let's plug 5 in for x. So let's find f prime of 5. Because that was a given point. So 5 minus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. So that equals, let's see here, equals 1/4. Oh, sorry, I'm going to make that mistake, aren't I? 5 minus 4 is 1. Square root of 1 is 1, and 1 times 2 is 2, 1/2. All right, so my derivative, or my slope, for my original function at the point 5, 1 is 1/2. Now we need to find the derivative of the inverse and use the given point of 1, 5, and we want to see if the slopes are reciprocals of each other. Which simply means if I were to draw um, a line tangent to the curve at those 2 points, those two tangent lines, well, should be parallel to each other. So let's look at f of -1, which is equal to x squared plus 4. Therefore, f -1 of x prime is equal to 2x. Now we were given the point 1,5 here, so let's let x equal 1. So 2 times 1, which is 2. Those derivatives are reciprocals of each other, which means if I were to graph these two curves, put a point at 5, 1 on the original curve, on the original function, and 1, 5 on the inverse function, and drew a tangent line through both of those, then you would see that those two tangent lines are parallel to each other. Alrighty, good people. Make sure you watch this video once or twice or 3 times if you need to. I hope you found the video to be helpful, and I will see you on the next one. Thank you.